Hi everyone, this is our website for the project. As discussed earlier that we are demonstrating the contrast network analyses for anti-gender based violence campaigns which are present on social media. So majorly we are focused on three campaigns, namely It's On Us, State of Women, and He for She. I will also take you to their individual pages on social media, namely Twitter. But before that, let's actually understand the main purpose of this project. So, our goal today is to understand the reach of these gender equality campaigns on social media platform across United States, which means how people interact to these campaigns on day-to-day basis. So let's start with their pages on Twitter. So the first one is for It's On Us. The second is for the State of Women. And finally, we have for He for She campaign. So now let's go back to our website. And here we see that we have divided the data for different 7 days that we have collected for in segments, and all these segments consists of graphs of individual days wherein we have recorded the interaction. So let's start with one of these dates, let's say 18th June. So now we have two more options inside. The first one is network graph and the other one is detailed network graph. So they're essentially the same, but the difference is in the network graph is like interactive version wherein you can actually scroll through the nodes, and also along with you can just drag and drop to better understand the network. And the detailed network is essentially the the network where you would see the Twitter icon along with the name of the users and yeah, obviously the network itself. So let's start with the network graph in here. Okay, so it is populating now, and so yeah, it forms the network segments, and we see the center bulk part, which is called the giant component in a network. And in on this side, left hand side bottom, we see this circle along across this point, and this is called the star feature, which basically is the retweets, replies, or mention from various users, and this person majorly started the conversation. We can also see these individual uh, nodes in here which are called singleton. So as I said, this thing is interactive, so if I just drag this thing up till here, it takes the network with it. So yeah, we can just understand their um, majorly their bond. Like if I want to, I don't know what this node is connected to, or what other nodes it is connected to. If I just stretch it a little bit here, then okay, maybe I can just read it. But since yes, this network is really big, we maybe need more space on the page. So let's go on to the other side of it, and let's see about the detailed network graph, which I said earlier is essentially the same with, but it has the Twitter icon along with the screen names. And here again we see we see kind of the same thing. See the circles along with their names in here, but this one is non-interactive, so I cannot really drag them. So okay, let's go back to our home page. We just tried for the 18th June. Let's try for 19th June now, and let's go into the network graph. So the first thing that we notice in here is the graph is little sparse than the previous one. So This has less interactions, or let's say the interactions on 19th June are comparatively less than the interactions on the day before. So let's just quickly go back. This again follows the same pattern of, like, if I have my mouse in here, I can just drag and drop. So let's go to the next date. So this network is even more sparse and scattered. We see less tweets, we see less communication or interaction. Again, let's go to the next date, which is the last date that we monitored here. And yeah, so basically here it's the least dense network. And yeah, again, it represents all its component, the giant one, the star or the singleton. And yes, it does follow the interaction which it is supposed to. And if I just drag it here, so it takes its node with it. And yeah, that's it.
I am going to talk about how we implemented our project. So the very first stage in our project was to collect data from Twitter. To accomplish this task, we used Twitter R package, and we collected data for 1 week after the announcement of State of Women campaign. So the next step in our project was to fetch mention, reply, retweets, thread in tweet post and construct a conversation network. For this, we used a Java code, and we were basically interested in 4 fields only: tweet ID, tweet, publish date, and author. The output of this code is GDF file, which consists of node list and edge list. So here you can see the edge list. Edge list is basically source target pair, like Kashif F Togra 84 has a edge to UN woman whose weight is 1.0, and this is the node list. So then after the creation of GDF file, our next step is to input the file to Gephi. So we inputted our file to Gephi and we got a network graph like this. And we used layout algorithms such as Frenchman Reingold and Force Atlas 2 in order to draw graphs. After that, we calculated various network centralities such as betweenness centrality, eigenvector centrality. So suppose if you want to find the average weight degree, so you have to run this. So here you can see the degree distribution. Most of nodes have degrees between 0 to 20. So this you can interpret it from the graph, and the average weight degree is 1.6. So now if I want to run the network diameter, so you can see the network diameter is 3 and the average path length is 1.3, and here you can see the graph for betweenness centrality also and closeness centrality. So basically we can see centralities for individual by going to data laboratory. So here you can see the in degree for each node and weight degree, closeness centrality, betweenness centrality and clustering coefficient for each node. So this process we have to repeat for each day in order to construct a network contrast network analysis between different days. As you can see from the visualization of the graph, it's not that great, and also we can't import such graphs to web. So in order to overcome this problem, we used d3.js, which allows us to bind arbitrary data to a DOM and then apply data driven transformation to document. So here you can see the D3 code. So this is basically a D3 code to generate the network graph. So in this you have to input a JSON file and then you have to create a SVG layer on the web page. So here you can see the various functionalities, like we added drag and drop functionality to the graph, and this is the code for the detailed network graph. So this also takes the new JSON file as a format, and what the essential difference between them is, like, it takes its icon from the web. So this is the detailed network graph, and this is the detailed network graph also. So here you can see it takes the uh, Twitter icon from the web and then assigns to each node. Then the final step was to design a web page. So for this we used HTML, CSS and JavaScript in order to achieve this task. So this is our very front page. So this is for various buttons we have implemented in our website. And then at last we integrated t3.js in our website. So that's all